Hi, I'm Roger Dannenberg, and this is Introduction to Computer Music. I was in high school when I discovered computers, and I was really fascinated by the ability to instruct a machine to carry out operations and to automate things. And at the same time, or around the same time, I discovered synthesizers, which were analog at the time. And once again, the ability to control things and to create my own sounds and just the interesting sounds that were coming out of these synthesizers was completely fascinating to me. And I thought that if these could be put together so that computers could be instructed to control and create new sounds, that would just be a fantastic playground. And over time, I learned what other people were doing. I started doing my own research and development and started writing music. I've had the opportunity to perform a lot with computers, and this has just been a fascinating career for me. I've also been doing a lot of teaching and trying to share what I know with other people. So I'm really excited to offer this course, and I hope you will share some of the excitement that I do about this ability to make new sounds and new pathways in music. In this introduction, I want to spend a few minutes talking about why computer music is special, or why I think it's special, and we'll talk a little about the details of the course and how the course is taught. So why computer music? One of the big attractions of computer music and digital audio in particular is that there are no limits to the range of sounds that you can explore. If you're dealing with instrumental music or vocal music or almost any other kind of music, you're dealing with a certain range of sounds and styles and possibilities. And these, any limitations are removed when you work with digital audio because it can represent really any kind of sound. The second thing that computers bring is precision. Computers allow us to make microscopic changes in sounds. Computers allow us to perform operations repeatedly, making very small incremental changes so that you can really perfect a sound, or with a lot of work, you can develop and refine sounds to make them exactly the way you want them, as opposed to, for example, working with an instrumentalist who might be a wonderful musician, but is never going to play something exactly the same way twice. The ability of computers to automate decisions and just the whole realm of computation is a very important part of computer music. We can embed decisions about music making at any level, from the highest level of composition and form and structure down to the most tiny detail of an individual sound. And we can hear the results of these decisions, and then we can change our programs and immediately hear the results of our changes. So unlike working with conventional music where you might have to recopy a score in order to make some big changes, with computers you can make incremental changes and have very broad effects and see what are the implications of decisions that you make in programming. And finally, computers can blur the lines between the traditional roles of the composer and the performer and even the audience. We can build interactive systems where composition is actually taking place in real time. Perhaps music is reacting to an audience, so it raises the question of who is actually performing the piece. and so on. So let's talk about the course. The course has two main components: computer music technology and making music. And of course, making music is really important. But we'll start with computer music technology. We're addressing that from two directions. First, there's theory. What are the concepts? We'll cover things like digital audio, digital signal processing, software design and languages, data structures and representation. All of these from a conceptual level to give you the background that you need to really understand the field. And then the second part of this is putting these concepts into practice to make them more concrete and practical. And so the practice part of computer music technology for this course consists of writing programs in Nyquist, which is a composition and sound synthesis language. It's very powerful for manipulating sound and doing sound synthesis. And also we'll use Audacity, which is a digital audio editor. So the second goal of the course is making music with computers. And again, there's a theoretical and a practical aspect of that. The theory part is mostly going to be listening and discussion of existing pieces of music. And the practice part is that you will be creating your own compositions. Again, using the concepts that you learn and using the practical knowledge of using Nyquist as a composition and synthesis language. So speaking of projects, there's a schedule on the web. Projects are all due before midnight on the date given. And if you're late, it's okay to be up to 1 day late 3 times, no questions asked, but try to reserve your 3 grace days for when you truly need them, and don't just get lazy and submit the first 3 projects a day late, because there won't be any more excuses later. You'll also find as you go through these lectures, the lectures will stop and ask you questions and give you exercises to work through that will be graded immediately online, and that will help you prepare for the projects and help you prepare for the class sessions. There are a number of online resources for the course. There is our website, and here's the URL. There's online instruction, but you're probably watching this online right now, so you've already found that. The syllabus is on the website, along with project information, schedules, assignments. You must come to class in this course. It seems like you can do everything online, but the in-class component of the course is extremely important. It's a complement to the online part. There's an online discussion system called Piazza that we're using this semester. It allows you to ask questions and get very rapid answers during the week, which I think you will find very helpful when you're facing deadlines. And finally, the projects are handed into AutoLab. Instructions for this are on the syllabus. You'll need a computer to take this class for homework and projects and online instruction. This can be a Mac, a Windows machine, or Linux is okay. No machine is going to be too slow. It's unlikely that you'll have memory problems, but you will need a gigabyte or so of disk space to store and work on projects. The projects are submitted over the network, so you'll need some network bandwidth. Probably you're okay. If you have a slow network connection, you can always put your work onto a flash drive or something and come to campus and upload from there. For software in the class, we're using two open source, free, cross-platform programs, mainly. The first of these is Nyquist, which is a self-contained language for sound synthesis and composition. You'll be using that a lot. You'll also need an audio editor, and if you're not already using and comfortable with one, then we recommend using Audacity. It's also free and open source. You can use other languages, editors, tools, pretty much anything you want to in the class, but you should think of using these in addition to, rather than instead of using Nyquist. So for example, if you have a favorite reverberation tool in an audio editor that you love, and you want to do some final addition of reverberation to a piece that you created with Nyquist, well, go ahead. Make it sound the way you like. However, the project descriptions will generally ask for certain things to be done in Nyquist, and we expect you to do that and turn in your code and so on. So welcome to the course. Now is a good time to download Nyquist. Here's a URL for that, and download and install Audacity. Here's a URL for that. So get things running, try them out, and get ready to make some music.